Hello everyone. How are you guys? And how about your studies? All good? That's really nice of you guys. How are you guys? And how about I was just checking whether I'm audible to you or not. Isn't it? And I have checked it that I'm very much audible and visible to all you guys. Once again, a very warm welcome to your very own channel. Let's crack NEET UG in English. Myself, Sharada Alok. I have been teaching chemistry at Resonance from past 10 years. How you can get connected to us? Guys, first of all, go to Play Store, then download the Unacademy Learning app and then click on to NEET UG. Before you go ahead for the subscription, let me tell you the benefit of taking plus subscription, guys. You'll be getting here daily live classes where you'll be taught by the top educators across the nation. Not only that, you can chat with your educator, engage in discussion, you can ask all your doubts and answer in the polls. These polls will be having questions related to the topic being taught on the screen. I'm repeating, these polls will be having questions related to the topic being taught on the screen. Okay, all while the class is going on. Not only that, you'll be getting live test, guys, which is going to evaluate your preparation on a regular mock test. You'll be having quizzes as well and get detailed analysis on your performance. Guys, there are so many benefits of participating in this quiz. The first of all benefit is it is going to sharpen your IQ because in a limited period of time, you're supposed to answer. Welcome, Ekagra. How about your studies, dear? Because in a limited time period you're supposed to answer a particular question, guys. So gradually, when more you just face the quiz, the more you become expert of it. Secondly, guys, you will be, yes, what, you will able to minimize your negative marking. Minimize your negative marking. Is that clear? Why? Because the same question will be asked in many of the quiz. And after the question is asked on the screen, the question is discussed properly. That is going to clear your topic related to which the question is related to. And then gradually what is going to happen? Your negative marking is going to decrease. If the same question is going to be asked in MCQ, like whether you are doing the practice or the exam or any kind of test, if you happen to see that particular question again, what is going to happen? You don't make the mistake again and again, isn't it? Not only that, you'll be getting highest referral point if you win the quiz, out of which you can buy any of the courses running at an academy platform. Hello, Arpita. How are you, dear? How about your studies? Not only that, you'll be getting structured course. All our courses are structured very much in line with your exam syllabus, which is definitely going to help you best prepare for it. Guys, just by taking one subscription, yes, just by getting one subscription, you get access to all our live and recorded courses, which you can watch from the comfort of any of your devices. Is that clear, guys? Now, guys, what is the benefit of this iconic subscription? This is going to take your NEET UG preparation to the next level, guys, with personal coach. Yes, the top educators will be your personal coach. You'll be getting one-on-one guidance from top exam expert as your personal coach, which is going to help you to align your preparation strategy. Not only that, you'll be getting an in-depth test analysis with personalized feedback, which is definitely going to improve your time management and exam approach, guys. You'll be getting study planner, which is going to ace your preparation with customized study plan. You are going to get bi-weekly reviews. I'm all fine, dear. Thank you for asking that. I'm all fine. How are you all guys doing? You'll be getting a bi-weekly reviews that is definitely going to highlight your progress. Not only that guys, just by having one iconic subscription, you get access to live classes from top educators, mock tests and quizzes, structured batch course, very much in line with the exam syllabus. Guys, whether to go for plus or iconic one, let me tell you the difference between the two. Whatever you are supposed to get under plus subscription, you'll be getting under iconic one, and these are the iconic features under this additional features which you don't get under plus subscription. What are that? Personal coach, you'll be getting study planner, expert guidelines, and of course an in-depth test analysis. Guys, how much you have to pay if you want to go for iconic subscription? Let me tell you. For 6 month, 12 month, and 24-month subscription are available under this. And for 6 months, you are supposed to pay 38,000. That is going to cost you only 6,333 rupees per month. And for 1 year, you will have to pay 65,000. That costs you around 5,417 rupees only per month. And for 2 years subscription, you'll have to pay 1 lakh rupees. That costs you around 4,167. Lakia Minimaran, hello beta. I saw your translation last night. You said Ikai Vinu. Something was that. What would you please repeat that for me? Really wonderful to see you here, Ika Lakia Manimaran. Really wonderful to see you guys. Do one thing, all you guys who are watching it, do share to all your near and dear ones. Guys. But if you apply this referral code of mine, but it is not correctly written over here, this should be SA10. All are of same size, guys. When you apply this referral code of mine, you'll be getting what? Yes, you are going to get this discounted prices. For 6 months, you are supposed to pay 34,200. For 12 months, you'll have to pay only 58,500. And for 2 years, you're supposed to pay 90,000. Yes, guys, and all these are available at no cost EMI. Okay, guys, don't forget to apply this referral code of mine, but please do write this as SA1 and 0 are all of them will be of equal size. All those who are watching, do like the video, do share to all your friends who are preparing for NEET 2021, 2022, or guys, or half yearly examination, board examination, JEE mains, JEE advanced, and of course KVPY. Guys, how much you have to pay if you want to go for plus subscription? Elakia is saying that last class I said I'm new to your class, but this is your second class, isn't it? Wonderful, wonderful. So happy to see you all, guys. Those who are watching, I just want to tell you to share it to your near and dear ones, and do like the video if you have not done so. And all those who are watching this channel for the first time, let's crack NEET UG in English. Do subscribe it without any delay, and don't forget to press the bell icon in order to have further notification, guys. So, guys, right from 1 month to 2 years subscription are there, and a plus subscription, guys. Okay, what are you just I just want to tell you how much you have to pay. If you really want to go for 1 month, you are supposed to pay 7,000. For 3 months, you will have to pay 17,500. For 6 months, you'll have to pay 28,000. For 1 year, I would recommend you, in fact, if you are a dropper student or in class 12, you must go for this 1 year subscription by paying 38,500. That is going to cost you 3,208 rupees per month only. And for 12, I mean for 11, if you are in 11, I would recommend you personally, you must go for this 2 year subscription by paying 56,000. That is going to cost you only 2,333. It is available at the cheapest, in fact most economical cost in comparison to all whatever we are with us on the online platform. Yes, you can confirm it yourself, but don't forget to apply this referral code of mine, guys, SA10, in order to have so many perks, kind of, you can say response from my side, which you'll come to know once you take this subscription by applying my referral code SA10. Remember, SA10 are all of same size to be written. Ikagra, wonderful, ma'am. It's so pleasant to be taught from you. Think I'm as worthy as Thor. Oh my God. I'm just, in the seventh, what should I say? I'm in this cloud seven. Yeah. All those who are watching, do like the video, do share it. If you have not subscribed the channel so far, do that. If you have not pressed the bell icon, do so. And all those who have not liked the video, do like, do share. Come on, guys, have a look on the screen. So what are the benefit of plus subscription? Let us look at it once again, guys. You'll be getting daily live classes, you'll be getting live test and quizzes, you'll be getting structured course, and yes, but just by having one subscription, you get access to all our live and recorded courses, which you can watch from comfort of any of your devices which you are having. Come on, guys, we're soon going to start the class. In fact, we are going to start the class now. Let's start the discussion of D block, important questions of D block elements. Come on, don't delay any longer. Share it all to your near and dear ones. Okay, guys, all who are preparing for NEET 2021, 2022, or guys, or what? Yes, J mains, advanced, KVPY, board examination, half yearly, or some of you might be preparing for what? For improvement. Please do share this link to the video to all those. Arpita, wonderful ma'am. I know that you are the best chemistry teacher ever. We'll rock NEET together. Thank you very much. All the best to you all, guys. All those who are watching, all the best to you all, and all those who are not watching but aspiring for NEET 2021. My heartiest wishes for all you guys, that you all are going to make it this time. All the very best. Let us start now, guys. All those who are watching, do like the video, do share it with. We are soon going to start the class, guys. These transition metal ions are what are colored. You can see the color of titanium or different oxidation state of vanadium. The color also differ with the oxidation state. Then different oxidation state of chromium, that of manganese, iron, cobalt, nickel, and copper, guys. These are the colors of their aqueous solution. Why do they so color, and many more things we are going to study in today's class, guys. Yes, we are going to discuss all of them in today's class. All those who are watching, do like the video, do share it, guys. D block elements are, always remember, all metal except mercury are solid at room temperature, whereas mercury is in liquid state. The elements of D block are generally called as transition metal because they show variable oxidation state. What? They show variable oxidation state, or you can say their properties keep varying. Yes, guys, their properties keep on changing, therefore they are called as transition state. Okay, guys, is that clear? The metal like silver, copper, gold are used in making coins, therefore they are also called as coinage metals. What do we call them? Coinage metals, because they once upon a time in history, now also, but there was a time in history when all the currency exchanges are in our country used to take place with the coins, and those coins were made of silver, copper, and gold. Once upon a time in history. Okay, guys, that's very nice of you. Now it is very clear, right from third group, guys, third group to 12th group, all the elements are called as, yes, what do we call them? We call them as D block element. Guys, zinc, cadmium, and mercury, we don't call them as transition metal. Okay, guys, because in most in their d orbital is almost filled, isn't it? Their d orbitals is almost filled, and transition metals are only those where d orbitals are partially filled, either in their elemental state or in the most stable oxidation state. Is that clear? Always remember that. Therefore, zinc, cadmium, and mercury are also called not to be true transition metals. I'm repeating, they are called not to be true transition metals because their d orbitals are completely filled. Is that clear, guys? Let us have a look at the questions for which you all are waiting for. By the time, come on, if you have not shared the video to all your friends who are preparing for NEET 2021, 2022 board examination, those who are preparing for board or for improvement or for KVPY or for J mains or J advanced, do share the link of the video to all of them, guys, to all of them. And all those who are watching, just all your eyes on the screen, take your pen and copy in your hand, and let us study that now. Now, the very first question, guys. Ekagri is saying, you're very funny and very intelligent teacher. This is the best combination for every student. Thank you so much for the compliment to all you guys. Thank you so much, Ekagri, for this wonderful compliment. And all those, thank you so very much for liking the video. Do share it if you have not done so. And all those who are watching this channel for the first time, let's crack NEET UG in English. Let's crack NEET UG together. So do subscribe the channel. And if you have not, press the bell icon, do so. So the first question under this, guys, is silver atom has completely filled d orbital, so it has 4d10 in its ground state. How can you say that it is a transition metal? Guys, the real definition, the exact definition of transition metal is those d block elements. I'm repeating, those d block elements in which the d orbitals are partially filled either in the most stable oxidation state, okay, or either in the most stable oxidation state or in their ground state or in elemental state, guys. Is that clear? Ground state. Is that clear, guys? This is actually the true definition of transition element. And as silver, the most stable oxidation state, silver shows, guys, silver shows Ag plus and Ag2 plus oxidation state. Is that clear? These are the two state, oxidation state shown by silver, that is plus 1 and plus 2. Is that clear, guys? It shows plus 2 oxidation state when this combines with oxygen to form AgO, or it combines with fluorine to form Ag2F. In that case, it exists as plus 2 oxidation state. But guys, always remember, the higher possible higher oxidation state of any element of is possible of especially d block element is generally seen with most electronegative element like oxygen and fluorine, because they have the capacity to take out max of the electron out of the element. Is that clear? Is that clear? Arpita ma'am, I got to say, you have made me your fan. You are awesome. Thank you so much. And all those who are watching, do like the video, do share it, do share it. Okay, guys, now, guys, if Ag2 plus, Ag2 plus, in case of Ag2 plus, guys, the electrons in 4D are 9. Okay, is that clear? In 4D are in the 4dr 9 electrons are there, so you can say that in this the d subshell is incompletely filled, or you can say it is partially filled. Is that clear, guys? Is that clear? So in plus 1 oxidation state, it is 4d10 Ag plus, it is 4d10, and in Ag2 plus, it is 4d9, or you can say the d orbitals are partially filled. Is that clear? The orbitals are partially filled. Therefore, guys, what? What? It is a transition metal. Is that clear, guys? Come on. Coinage metals. Do remember the coinage metals, guys. Copper, silver, and gold are the coinage metals. Let's have a look at the next question. In 3D series, scandium with atomic number 21 to zinc with atomic number, make it to zinc with atomic number 30, the enthalpy of atomization of zinc is lowest, that is 126 kilojoule per mole. Why does it so? I'm repeating, why does it so? By the time I just want to have a sip of water. Remember, guys, remember, this enthalpy of atomization means what? The energy required, all these metals are the individual metals are actually present in the kernels, guys. What? The kernels. So this is how the metallic bonding looks like between the kernel and the mobile electron. Metallic bonding, guys, the atoms of zinc are present here, or scandium, or any metal. Actually, the atoms are present like this as it is shown in the figure, but this bigger one is actually what? This bigger one are actually representing the kernels, and this kernel actually includes what? This kernels actually includes what? This kernels actually includes nucleus and inner electron. Is that clear? Is that clear, guys? These kernels include nucleus and what? These kernels include nucleus and inner electrons. I hope it is very, very clear, guys. These kernels include nucleus and inner electron. Is that clear? Is that clear, guys? Nucleus, let me take the eraser first. This nucleus includes nucleus plus inner electrons are these kernels, and these kernels are attracted towards each other by these mobile electrons. Guys, these mobile electrons are basically the valence electrons. Okay, these kernels are tightly these kernels are tightly packed or tightly attracted towards each other by these mobile electrons. Is that clear? Is that clear, guys? Now, what happens? Remember these metallic bonding, guys. This metallic bonding is going to be directly proportional to number of mobile electrons. What does that mean? More the mobile electron, more stronger the metallic bonding will be. Is that clear? And stronger the metallic bonding means these kernels are tightly packed. Tighter the, more tighter, more tightly the kernels are packed means higher the enthalpy of atomization. That is, you'll have to provide more energy in order to separate them. Is that clear? All those who are watching, do like the video, do share it, guys. To all those who are preparing for NEET 2021, 2022 JEE Mains Board Examination, advance, or for improvement, those who are working for improvements or preparing for KBPY, do share them as well. So enthalpy of atomization, you can say this enthalpy of atomization is again going to be directly proportional to number of mobile electrons. Is that clear? It is going to be directly proportional to number of mobile electrons. All done, guys. Now, what happens in case of scandium to zinc? Guys, in case of scandium, or gradually more the number of electron enters into d orbital. Okay, so mobile electrons basically in d orbital. Remember, in case of d orbital, the mobile electrons are actually d electrons d electrons as well as s electrons. Okay, okay, guys. Therefore, more number of mobile electrons are present with them. But in case of zinc, guys, in case of zinc, as you know that 3d10, the d orbitals is completely filled. D orbital, all those who are watching, do like the video, do share it. D orbital is completely filled, and remember, do not, these d electrons do not do not participate in, d electrons do not participate in what? D electrons do not participate in bonding. Is that clear? D electrons do not participate in bonding. Are you getting this? D electrons do not participate in bonding. Only, guys. Only the S electrons participate in bonding. Only the s electron participate in bonding. Therefore, you can say as the number of mobile electrons in d orbitals which participate are less, therefore metallic bonding is less. And as metallic bonding is less, therefore enthalpy of atomization is also less. Is that clear? Is that clear? So one line answer is d electrons are not involved in the formation of metallic bonding in case of d orbital, because it is completely filled, guys. Therefore metallic bonding is weaker, or metallic bond is weaker. So by providing less energy, we can separate the atom, or you can say the enthalpy of atomization of zinc is lowest because of this reason only. All those who are watching, do like the video, do share it if you have not liked or shared, and do subscribe the channel who are watching it for the first time, and do press the bell icon too. Now, guys, the next question: which of the 3D series of transition metal exhibits the largest number of oxidation state, and why? Okay, and why? Are you getting this question? Guys, 3D transition series amongst all. Guys, it is actually it is manganese. It is manganese which shows maximum oxidation state, because manganese, the electron, I mean 3D has 5 electron, all are unpaired. Then guys, how many electron? 4s2. So guys, all these electrons are lost gradually, one by one. For example, you can see in case of MnO, in case of MnO, the oxidation state is +2. In case of this, the +3. Here, MnO2 +4. In this case, it is +5. In K2MnO4, it is +6. In KMnO4, all the 7 electrons are lost. So you can say that actually it is manganese amongst all 3D metal, 3D series of transition metal, which shows maximum oxidation state, that is up to +7. That is up to +7. Ma'am, you are a good teacher of chemistry. Just keep it up. Love you. Thank you so much, Vita. Thank you so much. Okay, guys, is that clear? Okay, is that clear? Yeah, guys. Yeah, this is clear that manganese can lose all its 7 electron. So the maximum oxidation state can be shown by which element? Manganese. Is that clear, guys? And why does this happen, guys? 3D and 4S. Remember, 3D and 4S are close in energy, are very close in energy, guys. Okay, so it has maximum number of electron to lose or share, because they are almost of same energy. So all the electrons which are present in 3D and 4s are or can be lost. Okay, guys, is that clear? Hence is shows oxidation state right from +2 to +7 as shown the screen. Is that clear, guys? Is that clear? Well done. Shall we go ahead? Now, guys, the next one is the E naught value for copper is positive, that is 0.34 volt. What is possible reason for this? Guys, this E naught M2 plus M. Come on, if it is written like this, M2 plus M. First, +2 oxidation state is shown above the slash. Below that, the reduced state of metal. That means this type of representation is reduction potential. I'm repeating, this type of representation is called as reduction potential. Or if it is shown like this, if M is above the slash and M2 plus is below the slash, it will be oxidation potential. It will be oxidation potential, guys. Is that clear? Is that clear? Okay, all clear, guys? Oxidation potential, is this clear? Now, guys, we have to talk in this question. It is reduction potential mentioned. Is that clear? What is the definition of reduction potential, guys? Let me tell you. Reduction potential is defined as tendency of a chemical species to be reduced by gaining an electron. Or you can say reduction potential actually talks about the tendency to reduce itself, or the tendency to get reduced. Tendency to reduce itself, or tendency to get reduced, guys. Tendency to get reduced. Thank you so much for the compliment. All those who are watching, do like the video. Do like the video and do share it, guys. And always remember that reduction potential with electrochemical reference of hydrogen is calculated out, and electrode this reduction potential of hydrogen is considered to be 0. Okay, guys, is that clear? Individually you can never calculate the reduction potential. You'll have to always couple it with hydrogen electrode. And remember, the reduction potential of hydrogen electrode is considered as 0. Is that clear, guys? It is considered as 0. All clear? Now let us have a look here. In case of copper, why it is positive, M2 plus to M, the value reduction potential of copper from plus 2 to 0, or elemental state. Why the value is positive? What can be the reason? First of all, always remember guys, there are basically three reasons. I'm repeating basically there are three energies, some of three enthalpies are taken into consideration as long as we have to calculate out the reduction potential. Remember, the first one is, suppose M solid is converting into gas. For this, delta H is what? Sublimation, or you can say energy of atomization. Better you call it energy of atomization, guys. That is right from solid to gaseous state, and that is what? Energy of atomization. You always have to give energy. So this is positive, guys. Is that clear? And then you have to take out the electron. The second one is ionization enthalpy. What is the definition of ionization enthalpy? The energy required to remove the loosely bound electron from the outermost shell of an isolated gaseous atom. Is that clear? So Mg2 here, M2 plus, guys. M2 plus, all the two electrons we are talking about to take out here. Is that clear? Delta H ionization is H ionization, and remember, ionization energy will also be positive. You'll have to provide energy for atomization and as well as for ionization. And the third energy, guys, third energy which we talk is the hydration energy. M2 plus, then aqueous, that is water, will be represented as M2 plus aqueous. This is what? Hydrated ion. And during this, guys, during this, remember, delta H hydration, during this energy is released. So it is negative. Hydration enthalpy is negative, whereas enthalpy of atomization and enthalpy of ion are positive. Are positive, guys. Okay. Is that clear? So what happens? What happens, guys, in case of copper? Remember, copper has very high enthalpy. What? Enthalpy of atomization. It has very high enthalpy of atomization, or you can say energy absorbed, and low enthalpy of hydration. Low enthalpy of hydration. Remember, guys, it has low enthalpy of hydration. Are you getting this? High enthalpy of atomization and low enthalpy of hydration. Therefore, what happens? High energy is required to transform to Cu, to Cu2 plus. A lot of energy is required to ionize, to take out both the two electrons from copper in order to convert it to Cu2 plus. Or guys, the sum of all the three energy, the sum of all the three enthalpies, actually what? Of whether you talk about sublimation or ionization, is it not balanced by its hydration enthalpy? Therefore you can say the sum of all the three energies actually positive. Therefore the reduction potential of copper 2 plus to copper is what? Is positive. Is that clear? Because the reduction potential is sum of enthalpy of the three, whether you talk about enthalpy of atomization or enthalpy of ionization or enthalpy of hydration. Okay, guys, these two are very high, whereas this is very less. So the total sum of all the three is positive, and in case of copper 2 plus to copper, it comes out to be 0.34 volt. I hope straight away it is gone here. Is that clear? Is that clear? Guys, do like the video. All those who are watching, do share it and do subscribe the channel if you have not done so. Do press the bell icon if you have not done so. Guys, the next question: how would you account for the irregular variation of ionization enthalpy? Remember what enthalpy we are talking about: first and second ionization enthalpy in the first series of transition elements. First series means 3D series. So what is the question all about? It is asking for Irregular variation of ionization enthalpy. You can see in the diagram, it is there in the picture shown. First of all, the first ionization enthalpy decreases to vanadium till chromium almost same, then to magnesium, then iron, then cobalt, then nickel. There is a what? Where is a what? Irregular variation like this. And similarly, the second one also undergoes or have such irregular variation. What is the reason behind that? See, guys, what is the expected ionization energy as per the Z effective? Guys, across the period across the period, as we move, Z effective increases. Done. And what do we expect? Because ionization energy is directly proportional to Z effective. So what do we expect? That ionization energy will also increase across a period with increase in Z effective. Is that clear, guys? But it is only expected. It does not happen so. Why? Why there is an irregular variation, guys? Why there is an irregular variation? Because guys, removal of electron, remember, let me clear this. Actually, removal of electron takes place from where? PT-PCR, marvelous, ma'am. RT-PCR, thank you so much. Thank you so much. First of all, RT-PCR, what's your name, dear? Welcome to the channel and thank you so much for watching. Guys, removal of electron takes place from where? Please, all your eyes, all those who are watching, please watch it with full care, full attention on the screen. Guys, in this case, removal of electron takes place from 4s as well as 3d. Is that clear? Is that clear? Why? Because their energy is almost same. Or you can say as they have relative energy or comparable energy, removal of electron takes place from both of them. Or there is a reorganization energy. There is a reorganization energy accompanying ionization. Remember this very important term. There is a reorganization energy accompanying ionization. Is that clear? Because of which, guys, what happens? This results into release of exchange energy. Why? Because as the electron from, suppose, 4s1 4s2 is done, so what happens? Unpairing of electron will be taking place, or you can say half filled or fulfilled kind of arrangement goes away over there. So what it does the release. this results into this results into the release. This results into release of what? Exchange energy. Very important explanation, guys. This results into release of exchange energy, which increases as number of electron increases in dn configuration. So results into release of energy, and guys, this is directly proportional to number of electron in dn configuration, dn electron. Is that clear? And also from transfer of s electrons into d orbital. More and more s electron get transferred into d orbitals. Okay, guys, is that clear? Now, in case of this, you can see out of them chromium. Guys, chromium has lowest first ionization enthalpy. Look at the diagram given, shown here. Chromium has lowest what? First ionization energy. Because why it is taking place? Because loss of one electron gives stable configuration. Guys, the electronic configuration of chromium is written as chromium 4s1, yes, yes, 3d, 3d, 5. So what happens when this electron is removed or it turns into Cr plus 1? It forms 3d5, 4s0. Is that clear? Have a look here. Have a look here. So because of loss of one electron, it gives stable electronic configuration, or you can say d orbital becomes half filled. Is that clear? D orbitals becomes half filled. What do we call that? What do we call that, guys? Stable electronic configuration. And guys, zinc has very high ionization energy. In case of zinc, it is not shown here. It's somewhat here. It has very high ionization energy. Why zinc has very high ionization energy, guys? Because that acquires 3d10. After loss of both the two electron, it let me take the eraser, guys. Just a sec. We are taking RT-PCR. Yeah, it is crystal clear. Thank you so much for the compliment, RT-PCR. What's your name, dear? I just want to know. Zinc. Zinc, guys, it is 3D10. Is that clear? Zinc is 3D10. You can see that it is completely filled. Okay, so zinc has very high ionization energy because electron has to be removed from 4s orbital, which gives 3d10 electronic configuration, very stable electronic configuration. Is that clear? So this is the actual explanation for first ionization enthalpy. What? There is a reorganization in energy. Okay, guys, and it results into release of exchange energy. More and more electron from S goes into Dn. So more the Dn electron, more is the release of exchange energy. Is that clear, guys? Is that clear? Now, what is the reason for second ionization enthalpy? Let me erase this. Guys, if you talk about second ionization enthalpies, remember, after loss of one electron, Vishavan, hi ma'am, I am wake up. How are you? Vishavan, I am wake up. How are you? I am also fine. But you are waking up now. Good afternoon or good morning. What to say you? Go what to say you anyway. Welcome to the class. Anyhow, this is the best part that you are waking up to my class. You are not passing your time here and there. Straight away, you are watching my class. That is the best part of your but try to wake up early. But I won't say straight away come to the conclusion that you slept more. It might have happened that you have studied till till early morning. That is the reason you are sleeping till now. Am I right? Do let me know in the chat box, guys. After loss of one electron, okay, in order to take out the second electron, it becomes difficult. Why, guys? Because m plus is positively charged, and when you want to take out, just convert m2 plus and want to take out one electron because it is positively charged, and you want to take out one electron because positive and negative, lot of attraction, guys. So it is really difficult to take out second electron. Good afternoon, Veshwan. Good afternoon, dear. Yes, guys. So what happens to second ionization? It becomes very higher, and in general, guys, it increases from left to right. However, in case of chromium and copper, it is very clear that in this case has to be taken out from 3d5, and in this case it has to be taken out from 3d10. So what has happened? These values are much higher. Half felt stability. No, I slept at hours 1:30 to 2:30. ठीक है बेटा, ठीक है, बट थोड़ा सा ज्यादा सो गए, ऐसा नहीं है. Anyway, कल ध्यान रखना. Okay, guys, because you have to study all the four subjects, you should not forget. Okay, guys, in case of chromium and copper, the second ionization enthalpy is much higher because electron has to be taken out from half filled 3D in case of chromium and full filled 3D in case of copper. Is that clear? Is that clear, guys? Okay, let's go ahead for the next question. Now, guys, the next question: why is the highest oxidation state of a metal exhibited by fluorine and fluoride? It's fluoride and oxide only. Remember, fluorine is the most electronegative element with electronegativity 4. Pauling electronegativity 4. Oxygen is second most electronegative element. Second most electronegative what? Element. Is that clear, guys? With electronegativity value 3.5. Okay, all done. आ रहा है समझ में. Now, as these are extremely electronegative in nature, guys, okay, they can oxidize. They can oxidize the metal to its highest oxidation state. For example, if you talk about Mn, it forms MnO, sorry, MnO4, guys. Let me take an eraser, MnO4 minus. In this case, the oxidation state goes to +7. Or you talk about Cr2O7 2 minus, the oxidation state goes to +6. Or you talk about AgO, it forms Ag2O, guys, or Ag, yes, AgF, 2, isn't it? In this case, +2. Here also make it AgO. Ag2O में तो +1 ही दिखाएगा. AgO has +2 oxidation state. And it is all possible because oxygen and fluorine are most electronegative element, guys. Not only that, they have very, very small size. Or in nutshell, you can say due to small size, first one, and very high electronegativity, they show highest oxidation state. The oxidation number of atoms in any free uncombined element is 0. Sum of oxidation number of all element in compound is 0. This you all know, right? That, and the halogens, they always show -1 oxidation state, but in interhalogen compound they also show, other than fluorine will always show -1 oxidation state, isn't it? But other than fluorine, other halogen do show positive oxidation state. All clear, guys? All clear. Now the next question: which is stronger reducing agent? What is a reducing agent, guys? Remember, reducing agent or oxidizing agent. Most of the time, many of the students get confused under this. Yes, RT-PCR is saying interhalogen compound. All those who are watching, guys, do share. Do share the video to your friends, and those who have not liked the video so far, do like. Okay, guys, agent. Tell me, what does a travel agent do? A travel agent, what does a travel agent do? Yes, he makes tickets for others. Tickets for others. Done. What does an LIC agent does? What an LIC agent does? Makes LIC policies for others. Clear? So agent is one who serves others. Can we say? Thank you, RT-PCR. So agent is one who serves others. Travel agent, T for travel, T for tickets for others, making tickets for others. LIC agent, LIC policy, making LIC policy for others. Similarly, reducing agent will reduce others. I hope after this you are not going to get confused. Oxidizing agent oxidize others. Done. Thank you so much, RT-PCR, for the compliment. Reducing agent reduce others, oxidizing agent oxidize others. Is that clear? Now, the reducing agent reduces others and get oxidized. It get oxidized. Oxidizing agent oxidizes others and get reduced. Is that clear? It gets reduced or reduce itself. Here, get oxidized or oxidized itself. Is that clear? Is that clear? If you are going to remember reducing agent going to reduce other, you are always going to remember what it is going to do with itself. Is that clear? All those who are watching, do like the video. Travel, Ritik, welcome to the class. He's saying travel agent example was great, ma'am. Thank you so much, dear. Thank you so much. Wondering, you are planning for traveling, isn't it? Is it so or what? Okay, guys, have a look at the screen now. Oxidation and reduction must occur simultaneously. If an atom loses electrons, another atom must take them. The reactant that reduces an element in another reactant is called reducing agent. Similarly, the reactant that oxidizes an element in another reactant is called oxidizing agent. For case 1, मैम वन डाउट इन हाइड्रोकार्बन एट द लास्ट बेटा अभी क्या फ्लो टूट जाएगा इस लेक्चर का सो आई एम नॉट डिनाइंग वी आर गोइंग टू डिस्कस एट द लास्ट ऑफ द वीडियो यू डू रिकॉल मी okay at the end please recall me the doubt till then you please watch it carefully because it is also going to help you guys in this reaction sodium plus chlorine is forming sodium chloride done sodium is getting oxidized and chlorine is getting reduced okay why guys because sodium is converting from 0 to plus 1 increase in oxidation state so getting oxidized chlorine from 0 to minus so getting reduced guys because sodium is losing an electron and that electron is gained by chlorine okay because chlorine is accepting that electron therefore sodium is what सोडियम इज द रिड्यूसिंग एजेंट बिकॉज सोडियम ने इलेक्ट्रॉन दिया है तभी तो क्लोरीन ने एक्सेप्ट किया है एंड सोडियम का इलेक्ट्रॉन क्लोरीन ने लिया है तभी तो सोडियम ने ऑक्सीडाइज किया है देयरफॉर क्लोरीन इज द ऑक्सीडाइजिंग एजेंट एंड सोडियम इज द रिड्यूसिंग एजेंट okay RT-PCR is saying ma'am suggest the book please to be very honest RT-PCR the books are actually for the educators आप लोगों के लिए तो वीडियो देखो और प्रैक्टिस करो कि जस्ट वीडियो देखो एमसीक्यूज प्रैक्टिस करो डाउट क्लास का वीडियो देखो और अपने कंसेप्ट क्लियर करो बेटा बुक्स वगैरह तो हम एडुकेटर्स के लिए होते हैं नॉट फॉर यू गाइज ओके इज दैट क्लियर बेटा ओके एमसीक्यू सॉल्व करो जितनी हो सकती है हमारा सबसे पहली कोशिश ये करो जो लर्निंग ऐप पे अनअकैडमी की लर्निंग ऐप पे जितना भी एमसीक्यू है उन सारे क्लास को सॉल्व कर लो पहले पहले आप लोगों को तो प्रैक्टिस करनी है बेटा जितना हो सके पहले सारा अनअकैडमी का मटेरियल सॉल्व कर लो उसके बाद आस्क मी फॉर सम ऑब्जेक्टिव लाइक एमसीक्यू प्रैक्टिसेस आई विल डेफिनेटली टेल यू डोंट वरी okay is that clear thank you for responding so quickly guys all those who are watching do like the video if you have not done so do share the video if you have not done so okay guys now the question here is which is a reducing agent देखो reducing agent क्या होता है oxidizing agent क्या होता है we have already done but the question is not that the question is which is a stronger reducing agent out of Cr2 plus and Fe2 plus is that clear this is the question guys this is the question come on guys have a look at the screen guys Cr2 plus okay Cr2 plus is a stronger reducing agent or SRA. Also, you can write it. Keshwan is saying, ma'am, I love chemistry. It creates interest me to solve MCQ and learn more about this. So nice of you, beta. Trust me. All those guys who are watching and all those who will watch the recorded video, I just want to tell you that more and more practice is going to make you perfect. Trust me and remember it will happen that many of the questions you may not able to solve it don't ignore those questions because they are actually more important the one which you are able to solve correctly are of course important but as you know them all the importance for you is not there of course the importance is there for the time of exam so you should revise them okay but guys all those questions which you are not able to click at a very first look or very first practice of it, you must discuss that with your educator. You must discuss. I keep many of the doubt clearing session at an academy platform. You can join me there at the platform of Unacademy, okay, by downloading the Unacademy learning app. Okay, you can watch all my doubt classes every time. Every week I keep at least one doubt class. You can bring all your doubts over there, and you must discuss those questions which you are not able to solve it at the time of solving MCQ. Okay, because that is more important, guys. All done? Have a look at the screen, guys. Stronger reducing agent. Cr2 plus is a stronger reducing agent than Fe2 plus. Why? Why, guys? Why does it happen? Why it is so? Let me tell you. Guys, the reduction potential of Cr3 plus to Cr2 plus is negative. Very, very important. It is negative, and no need to learn the value, but it is point 0 minus minus 0.4. Okay, point 4, make it 41 volt. All done. Ma'am, RT-PCR is saying, ma'am, more you sweeten peace, less you bleed in war. वंडरफुल बेटा, बहुत बढ़िया लाइन है ये. द मोर यू स्वेट इन पीस. ओके, दिस शुड बी स्वेट. जितना ज्यादा शांति में पसीना निकालेंगे, द मोर वी स्वेट इन पीस, द लेस वी ब्लीड इन वॉर. आई लव दिस बेटा, आई ट्रूली बिलीव इन इट. शांति में जितना ज्यादा पसीना निकालोगे, वॉर में उतना कम खून निकलेगा. बहुत बढ़िया बात बोली आपने, बहुत बढ़िया बात बोली बेटा. वेल डन. So guys, the reduction potential of chromium from 3 plus to 2 plus is minus 0.41 volt. Whereas, Keshwan, why these chapter differ from other P and S block element? बेटा, हर chapter different होता है. हर chapter एक दूसरे से different होता है. ठीक है? Now guys, now reduction potential of Fe3 plus to Fe2 plus is positive. How much it is? 0.77 volt. It is how much? 0.77 volt. All done? All done? Clear, hai, guys? Thus, what has happened? What has happened? Which has a greater tendency to get reduced, guys? See, Cr2 plus is easily oxidized. Remember, Cr2 plus is easily oxidized. Okay, guys. Therefore, it is a stronger reducing agent. Because it is negative, the Cr3 plus to Cr2 plus is very negative, guys. The reduction potential is very negative, whereas Fe3 plus to Fe2 plus is positive. Okay. Is that clear, guys? Is that clear? Is that clear? Therefore, Cr2 plus is a stronger reducing agent than Fe2 plus. Done? Clear? Well done, guys. Now, guys, acha, one more thing. These electrode potential, I have already made a video trick to remember electrochemical series in a separate video. Guys, if you really want to get access to that, do one thing. Let's crack NEET UG in English. Subscribe the channel if you have not done so. And the link for the same, or you also can go to the link given in description box. All playlist of my videos are there at this channel or the link. Okay, guys, you can watch this trick to remember electrochemical series. You need not to learn this value. If you will simply remember their position in electrochemical series, you can answer any of the question of this type. Okay, guys, is that clear? RT-PCR is saying nowadays NEET is asking questions from each and every topic, every chapter of NCERT. बिल्कुल बेटा, बिल्कुल. But अभी board में तो कुछ relaxation मिला हुआ है because of COVID. So the syllabus is not yet there for NEET. Let us see whether some topic from NEET also will be eradicated or not. But chances are less because you have sufficient enough time for NEET 2021. Okay, so chances are less. So we have to be very, very particular about it. No, beta, this is not. Keshwan is saying, ma'am, is it electrochemistry chapter? Na re, this is D block element. डी ब्लॉक एलिमेंट का डिस्कशन चल रहा है, बट डी ब्लॉक बहुत वास्ट है, बहुत वाइडर है. ओके. ओके गाइस, नाउ द नेक्स्ट क्वेश्चन. कैलकुलेट द spin only magnetic moment of M2 plus ion with Z, that is the atomic number 27. Is that clear? Is that clear, guys? Which is equal to N into N plus 2 Bm for Bohr magneton. ओके केशवान, आई नो बेटा, हो जाती है. बड़े बड़े लोगों से छोटी छोटी गलतियां हो जाती है केशवान. केशवान है सही, मैम आपने इलेक्ट्रोकेमिकल सीरीज बोली इसलिए मैंने बोला. नहीं बेटा, बताना तो पड़ता है ना, हर अच्छी चीज कुछ भी छूटना नहीं चाहिए. इट्स माय रिस्पॉन्सिबिलिटी टू मेक यू अवेयर, इजंट इट? अंकोश मैती, वेलकम टू द क्लास बेटा. What do you mean by this? I did not get Ankosh Mehti. Acha. Oh my God. This guy is answering. Wonderful. Ankosh Mehti, this too like is for you. First of all, welcome to the class. Welcome to the class. And first of all, yes, guys, welcome to the class. Secondary, guys, I'm really proud of you for answering this particular question in the chat box. I would like to tell you, all those who are watching, do answer in the chat box. I'm waiting for your answer in the chat box. Okay, guys, have a look. RT-PCR is also giving the value. Well done. Let us see. Let us see why it is possible. Guys, atomic number 27. What will be the electronic configuration? Let us write down the electronic configuration. Electronic configuration will be written as, well, the noble gas, that is argon. Then 3d7, 4s2. 3d7, 4s2. Is that clear, guys? Is that clear? Now, if it is M2 plus, for M2 plus, it will be written as argon 3d7. Is that clear? It will be written as argon 3d7. आई बात समझ में? It will be written as argon 3d7. Now let us fill the 3d, all the 5 orbital of 3d with 5 7 electrons. Okay, 1, 2, 3, 4, 5, then pairing 6 and 7. It is very, very clear, beta, from here that there are 3 unpaired electron. There are 3 unpaired electron. Now, Ankosh Mehti, you have answered well. Earlier you answered, but your answer was not correct. But even though I gave you 2 to like, because you joined the class and answered the question. Okay, but now your answer is correct. Now, guys, this is equal to n. N is equal to, n equals to 3. Put the value of n over here. It will become square root of 3 into 3 plus 2. Bohr magneton. BM. B stands for Bohr. M stands for magneton. Is that clear? The unit of spin only magnetic moment. So guys, this value is going to be 3 plus 2, 5, 5 3s are 15, square root of 15, and that is somewhat 3.87 Bohr magneton. Is that clear? Is that clear? The value is 3.87 Bohr magneton. All those who are watching, do like the video. If you have not done so, do share the video if you have not done so to all your friends who are in class 12 preparing for JEE Mains NEET 2021-2022 advanced board examination, or working for improvement of their board score or half yearly or KVPY. Do share to them. And those who are in class 12 board of ICSC, this is going to help them too. If you know any one of them, do share the video. Do share it. Now I'm going to give you a wonderful trick out of it. Is that clear? First, do let me know, is that clear? Take a screenshot. I'm going to clear the screen now. Take a screenshot. After that, I am going to give you a trick. so that Ankush, Modi, and all you guys will never make that mistake again. Why we at KD orbital? I did not get your question. Do write it again. Guys, have you taken the screenshot? Done. Let us clear the screen. Now, why we take d orbital? Yes. We should take. We are studying d orbital, guys. Therefore, they have unpaired electron because in case of S&P, all like inner orbitals are filled, isn't it, guys? Okay, all done. Now have a look here, guys. Remember, just by knowing the value of Nu without going calculation, you can predict the value of mu. How come? Guys, if n is 1, the value of mu will be 1 point something. If n is 2, the value of mu will be 2 point something. If n is 3, the value of mu will be 3 point something. If n is 4, the value of mu will be 4 point something. If n is 5, the value may be 5 point something. And in case of f orbital, the value may go to 6. It may go to 7, maximum 7, isn't it? That case, the value will be 6 point something or 7 point something. I hope straight away the trick has gone here. We need not to calculate all the time because most of the time square root का calculation थोड़ा सा difficult हो जाता है. या तो याद रखते हैं तो हो जाता है फटाफट से one trick में, but math student के लिए बहुत help होता है, but biology student का क्या? So this trick is going to work for biology student. You will straight. I don't mean to say that your calculation is weaker any longer, but there is nothing bad in saving the time, isn't it? थोड़ा सा time save हो रहा तो क्या बुराई है? Okay, if you know the value of n, mu value can be easily calculated out. थोड़ा सा time बचाने में कोई बुराई नहीं है. ठीक है जी. Is that clear जी? आगे बढ़ा जाए जी. All those who are watching, do like the video, do share जी, do share. Now the next question on the screen. Okay, RTPCR is saying great tricks. Thank you, beta. Thank you, RTPCR, for the compliment. Do share. सबको ये trick मिलना चाहिए, सबका फायदा होना चाहिए, isn't it? Guys. Explain why Cu plus ion is not stable in aqueous solution. Very important. Remember. This question is not important for this. This question is equally important for electrochemistry as well. Electrochemistry as well. Cu plus ion is not stable in aqueous solution. Why? Why Cu plus ion is not stable in aqueous solution? That is what? Cuprous. Cu plus is cuprous, whereas Cu2 plus is cupric. Is that clear? Let's have a look here. Cu plus goes disproportionation. When a particular oxidation state goes to oxidation as well as reduction, it is said to be disproportionation. So guys, here what is happening? One out of the two ion, one ion is reduced to copper, that is 0 oxidation state. So from +1 oxidation state, it is reduced to 0. The other one is getting oxidized to copper 2 plus ion. So in this case, it is what? It is what, guys? It is what? It is getting oxidized, right? From what? Right? From +1 to +2. Okay, so this is oxidation. This one is reduction. Both of them take place simultaneously. So this will be called as disproportionation. Is that clear? Is that clear? Are you getting it? Are you getting it, guys? Now let us see. Let us discuss the reason behind it. Okay, guys? Okay, now. Guys, Cu2 plus. Wait a sec. Let me take a yellow pen. Cu2 plus is much more stable than Cu plus. In aqueous state, remember, this is because अभी आपको मैंने बताया था that it has got reduction potential positive 0.34 volt. थोड़ी देर पहले हमने डिस्कस किया था. बिल्कुल. Okay, guys. Now, this is because second ionization enthalpy of copper is large. second ionization, just a sec, कैसे लिखेंगे second ionization enthalpy guys? Delta HIE2. Delta HIE2, this is representing second ionization enthalpy. All done? Done? Okay, is very, very large. Is very large. Okay. Okay, guys. And hydration enthalpy, delta HCU2 plus is what? Is remember, very, very important, guys. Delta H for Cu2 plus aqueous is much more negative. Much more negative. बहुत ज्यादा एनर्जी रिलीज हो रही है than लेकिन किससे? Much more negative than delta HCU plus aqueous. Okay, is that clear? Hence, it more than compensates for the second ionization enthalpy of copper. Therefore, many copper 1 compounds are unstable in aqueous solution and they undergo disproportionation as it is shown here. Is that clear, guys? Is that clear? So always remember 2 plus is much more stable than plus 1. Okay? Okay, guys, is that clear? Sure. Keshwan, I'm going to tell you once again in English. Okay, I'm going to tell you. Cu2 plus, guys, is much more stable than Cu plus in aqueous state. This is because second ionization enthalpy, guys, is very, very large. And hydration enthalpy of Cu2 plus is much more negative than for Cu plus. Okay. Hence, it more compensates for second ionization. This is more negative, guys. This is also more. But in this case, what? This is positive. Ionization enthalpy is positive. It is getting required. You have to give energy. Here it is getting released because it is negative. So this much more higher negative enthalpy compensates the second ionization enthalpy of copper. Therefore, copper 1 compounds are unstable in aqueous solution and they undergo disproportionation easily. Done. हो गया? Well done. Thank you for the compliment. Keshwan is saying, ma'am, it is done. समझ में आ गया. RTPCR is saying, ma'am, it is crystal clear, pretty clear. Okay. Thank you for the compliment, guys. All those who are watching and have not liked the video so far, do so. Have not shared the video so far, do so. Have not pressed the bell icon so far, do so. If you have not subscribed the channel so far, do so. Let's crack NEET UG in English. Subscribe it, guys. फायदे में रहोगे. Now, guys, the next question on the screen. Explain briefly how plus 2 state becomes more and more stable in first half of first row transition element with increasing atomic number. Thank you for the shield, easy peasy. Plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. Why is it so? Okay, guys, except scandium. Remember. Okay, guys, because it shows plus 3 oxidation state. Done. All other first row transition element shows an oxidation state of plus 2. It is due to the loss of from where? Yes, 4s2 electron. It is due to the loss of 4s2 electrons. All done? In the first half, as we move from Ti2 plus to Mn2 plus, electronic configuration, guys, how does it change? It changes from, yes, 3D2. In case of titanium, it is 3D2. To manganese, it is 3D5. Okay. Increases one electron, keep on increasing in d orbitals. Done. Or you can say more and more d orbitals are half filled. Yes, right from titanium to manganese. More and more d orbitals are half filled. Okay, imparting greater and greater stability, greater and greater stability to what? Plus 2 oxidation state. All done? All done, guys? All done? Now in second half, right from Fe to plus 2 to Zn2 plus what happens? What happens, guys? Electronic configuration changes from 3d6 to 3d10, or you can say pairing. Yes, pair up. Electrons get paired up. All clear? As we move from iron towards zinc, electrons gets paired up, or the number of half-filled orbital decreases. Number of half-filled orbitals decreases. Is that clear? Crystal clear or clear? Therefore, the stability of plus 2 decreases. In this case, plus 2 stability, though they show plus 2 oxidation state, but the stability decreases. Keshwan, Keshwan is saying, Ase prasanna rajya mandala madhye vikaralaya jau sakata. बेटा मुझे कुछ नहीं समझ में आया. Please केशवान, translate it for me dear, and for all those who are listening to me. मेरे ख्याल से आप में से भी किसी को समझ नहीं आया होगा. असे प्रसाना राजमन्या दालमाध्ये विकारलया जाऊ सकता. ओके, दिस इज तमिल. RTPCR सेइंग, मैम ये तो केशवान ने तमिल बोला है. बहुत अच्छी बात है. आई डू रेस्पेक्ट तमिल, बट प्लीज मतलब तो बता दे बेटा, नहीं आती तमिल, थोड़ा सा मतलब बता दे. ओके, प्लीज ट्रांसलेट इट केशवाना. Now guys, the next question on the screen. Name the oxometal anion of first series of transition metal in which the metal exhibit the oxidation state equal to group number. Acha. Keshwana is saying, ma'am, it is Marathi. It is not Tamil, but it is Marathi. Is this type of question asked in state board? ओके उनका कहना है कि ये जो प्रीवियस क्वेश्चन था, क्या ऐसे क्वेश्चन स्टेट बोर्ड में आ सकते हैं? बिल्कुल आ सकते हैं बेटा, बिल्कुल आ सकते हैं. स्टेट बोर्ड में मेरे ख्याल से स्टेट बोर्ड में अब तक नहीं आए, पर आ सकते हैं. चांसेस तो हर चीज का रहता है. मैं ऐसा तो बिल्कुल ही नहीं बोल सकती कि आ ही नहीं सकते. हाँ, चांसेस कम है, बट नीट में तो है. यू विल बी हैविंग दीज टाइप ऑफ क्वेश्चंस श्योरली इन नीट. ओके, बी प्रिपेयर्ड फॉर दैट. Now guys, the oxometal anions of first series of transition metal, because one more thing guys, ये line तो लिखी हुई है ना NCERT में. This line is written. If you will read line to line D block element, you will find this line is written over there. And I told you in the very first day that इनऑर्गेनिक केमिस्ट्री, इफ NCERT का लाइन टू लाइन पढ़ लिया तो आप नीट क्लियर कर सकते हो. केमिस्ट्री का इनऑर्गेनिक का एक भी क्वेश्चन इज नॉट गोइंग टू मिस बाय यू. Okay guys, but the only problem is what guys, if you will simply keep on reading the book now, trust me, answers are not going to click you at the time of examination. So that is the reason I have made this video specially for all you guys, in order to make your inorganic very scoring. Okay, in order to make you score better in inorganic. Done. Okay, because these topics might seem boring, but they are very scoring. Done. Is that okay? PT RTPCR, धन्यवाद madam. Thank you beta. Thank you so much. Okay, आगे बढ़ा जाए. Let us have the next question. Oxometal ions, first series of transition metal in which metal exhibit oxidation state equal to its group number. Let us calculate their oxidation state, guys. This is what this oxometal ion is dichromate ion. Oxygen shows -2. Guys, 7 oxygen, so -14. Then 2x plus -14 is going to be equal to -2. It will be 2x is equal to -2 plus 14, or it will be plus 12, or x will be equal to 12 by 2, that is plus 6. All done. And chromium belongs to which group? Tell me. Group number of oxidation state of chromium are 6. Chromium, scandium is what? Scandium, titanium. Yes, scandium, titanium, vanadium, chromium. Third group, fourth group, fifth group, sixth group. And okay, guys. Okay. So plus 6 oxidation state and sixth group. It is chromium. RT-PCR is saying, ma'am, PDF we can. Bilkul you can. Bilkul you can. Now, guys, in this case, the second one, let me take a red pen first of all. In this case, this is what? Mn. This is what? MnO4 minus. Beta, this is MnO4 minus. There are two double bond actually. MnO4 minus. Okay. Now in this case, what is happening? -2 for oxygen. So x minus 8 is equal to -1, or x is equal to +7. Okay. Manganese after chromium, what is that? Manganese. Manganese belongs to seventh group, and this also +7 oxidation state. Okay, all done. Let us have a look here. This is what? This is what, guys? This is what? Let me take a yellow pen here first of all. Guys, this is CrO4, 2 minus, oxygen is -2. So x minus 8 is equal to -2, or x is equal to -2 plus 8, that is +6. X is equal to +6. Okay, chromium belongs to sixth group and manganese belongs to seventh group. Is that clear? Is that clear? बिल्कुल सब कुछ मिल सकता है बेटा, सब कुछ मिलेगा. RT-PCR PDF तो क्या चीज है? You will get everything. Okay, guys. Okay, if you have any question, you can ask me. Otherwise, all those who are watching, if you have not liked the video, do so. If you have not shared the video, do so. And all those who have not subscribed the channel Let's Crack NEET UG in English, do so. In order to make this happen, this NEET 2021, in order to make it happen, do subscribe the channel Let's Crack NEET UG in English. Keshwan, please go ahead. If you have not subscribed the channel so far, do subscribe. If you have not pressed the bell icon, do press the bell icon in order to have further notification. And guys, before taking the subscription, don't forget to apply this referral code of mine, SA10. SA10. Is that clear? Okay, beta question kahan hai, Keshwan? How to find major and minor product in हाइड्रोकार्बन. केशवान का क्वेश्चन है, जैसा कि मैंने प्रॉमिस किया था, हाइड्रोकार्बन का क्वेश्चन मैं बीच में नहीं बट वीडियो के एंड में बताऊंगी. बेटा सेडजिफ अल्कीन, लुक फॉर सेडजिफ अल्कीन. ज़ैडसफ अल्कीन भी बोलते हैं. दैट इज व्हाट? मोर सब्स्टिट्यूटेड अल्कीन. Okay, and I have taught this separately in my video of SN1 और SN2. आप ये वाला वीडियो देखो, ये वाला वीडियो देखो, और SN1 वर्सेस SN2 वाला वीडियो देखो. बहुत सारे ऐसे क्वेश्चंस हैं which are based on stability of the product to be decided as per Setzef rule. Okay बेटा, do download those video. ओके, पॉज करके अच्छे से धीरे धीरे देख के नोट्स बना के देखो. आई एम श्योर योर डाउट्स आर गोइंग टू बी क्लियर देयर. इज दैट क्लियर, केशवान? RT-PCR is saying, ma'am, you are truly magnificent. Thank you for the compliment. And all those guys who are watching, not like the video so far, do so. If you have not shared the video so far, do so. If you have not subscribed the channel so far, do so. If you have not pressed the bell icon so far, do so. Guys, thank you for watching. All the very best for your examination. You all are going to make this NEET 2021 happen. And all those who are preparing for their examination, all the best to you all, guys. You'll rock this time. Thank you for watching, guys. Bye bye. Bye bye. Keshwan is saying in my language, Nandri. 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 All you guys, Nandri.